With the Rosetta Philae mission, the European Space Agency, ESA, earned global recognition. ESA achieved something even NASA had never attempted, sending a probe directly into the vicinity of a comet. This groundbreaking mission marked the first time such a close encounter with a comet had been accomplished. Studying comets holds immense significance for us here on Earth for two major reasons. First, comets are believed to be potential carriers of the building blocks of life, possibly playing a key role in how life began. On the flip side, comets also pose a serious threat. When these icy, organic-rich objects, sometimes several miles wide, collide with planets, they can cause destruction on an apocalyptic scale. One such comet is 67P/Churyumov, Gerasimenko, often shortened to Che. This 2.8 by 2.2 mile wide body is made up of rock, ice, and organic compounds. Originally, it was just one of many objects orbiting in the Kuiper belt, located at the edge of our solar system. Over time, Che's orbit shifted inward, and it is now classified as a Jupiter family comet. This means it follows a highly elliptical and irregular orbit that rarely extends beyond Jupiter. Scientists believe that Churyumov-Gerasimenko formed during the early days of the solar system, possibly from the very same cloud of dust and gas that gave birth to our Sun over 5 billion years ago. Compared to asteroids, comets are generally less massive, though not necessarily smaller. They tend to have irregular shapes, while asteroids are typically composed of dense rock and often contain a high concentration of metals. In contrast, comets are primarily made up of ice and organic compounds. This composition is precisely what makes comets so fascinating. They are considered potential carriers of life across the cosmos. Because they transport organic material through space, comets are currently regarded as the most likely candidates for spreading life beyond Earth. Scientists believe that comets like Churyumov-Gerasimenko, also known as Che or 67P, may act as cosmic messengers. One of the leading theories about how Earth, once a hot, lifeless planet, came to possess vast amounts of water and the basic building blocks of life points to comets as the source. The European Space Agency's Rosetta mission provided critical evidence for this idea. Even before it successfully deployed its lander onto the comet's surface, the Rosetta orbiter had already begun studying the surrounding environment. These early measurements revealed a surprising discovery: Churyumov-Gerasimenko has an unusual atmosphere. In addition to water vapor, carbon monoxide, and carbon dioxide, Rosetta detected large amounts of oxygen, making it the fourth most abundant gas found around the comet. This unexpected find sparked significant excitement within the scientific community. Oxygen is typically a highly reactive gas that disperses quickly, making its presence in space extremely rare. Until recently, scientists never believed that a relatively small object like a comet could retain large amounts of oxygen in its thin atmosphere. At this point, researchers can only speculate about the source of this oxygen. One theory suggests that the oxygen was trapped in the comet's ice during its formation. If that's the case, it would imply that the comet formed in a region of space where oxygen was readily available. To date, no planet in our solar system has been discovered with an atmosphere rich in oxygen that could support human life. Even Mars, which is currently being eyed for future colonization, has an atmosphere dominated by carbon dioxide. Humans living on Mars would need to wear helmets and carry their own oxygen supply to survive. This simple need to breathe reminds us of just how rare and extraordinary our own planet is. The perfect combination of conditions that allow life to thrive on Earth, breathable air, water, and a stable climate, remain among the greatest scientific mysteries. In its earliest days, Earth was a harsh, lifeless world, hot, barren, and toxic. Then, billions of years ago, water appeared, followed by the emergence of the first single-celled organisms. To this day, one of the biggest questions is whether these primitive life forms originated on Earth or came from somewhere else in the universe. This is one of the reasons behind the Rosetta mission. Rosetta is considered the European Space Agency's, ESA, most ambitious and successful space project to date. While ESA frequently collaborates with NASA and plays a major role in the International Space Station, ISS, Europe also aims to conduct independent missions with its own spacecraft and research goals. The exploration of comets and asteroids may soon become the centerpiece of European space travel. Understanding these celestial bodies is vital for life on Earth. In the asteroid belt located between Mars and Jupiter, there are an estimated 650,000 objects made of rock, ice, and metals. Fortunately, Jupiter's immense gravitational pull keeps most of these bodies in stable orbits, safely away from Earth. However, around a dozen known comets or asteroids have the potential to drift onto a collision course with our planet. These objects are under constant observation. Should one come dangerously close, we would need to deploy probes, such as the Rosetta Philae mission, to analyze their composition. Knowing whether they are made of rock or ice would be crucial in determining whether to destroy them or alter their trajectory. ESA's mission to study comet Churyumov-Gerasimenko represents a major milestone in this field. The Rosetta Philae probe, developed at the Friedrichshafen site of Germany's aerospace company EADS Astrium, was the result of collaboration among 17 nations and cost nearly €1 billion. Given the mission's tremendous success, Rosetta Philae is unlikely to be the last of its kind. It has paved the way for future planetary defense and deep space exploration missions. The probe was named after the Egyptian port city of Rosetta, and its lander after Philae Island in the Nile. Both locations are historically significant for the discovery of stone monuments that allowed humans to decipher ancient Egyptian hieroglyphs for the first time. Just as those breakthroughs illuminated the mysteries of Egyptian culture, the Rosetta Philae dual mission aimed to unlock secrets about the origin of life and water in space, as well as the structure and composition of comets. Before we explore whether the water discovered on the comet matches that found on Earth, let's first revisit the tense and dramatic moments surrounding the Philae lander's near failure and its most important scientific contributions. The Philae mission made history on November 12, 2014, when the European Space Agency, ESA, attempted something never done before, landing a spacecraft on a comet. That day, Rosetta released the Philae lander onto the surface of the comet. Technically, it was more of a drop than a controlled landing. Philae, a compact lander just 1 meter by 1 meter in size, was to touch down on a comet roughly 2.8 miles long and 2.2 miles wide, a feat considered one of the most challenging maneuvers in space exploration. Calculating Rosetta's orbital path to align with the fast-moving comet posed a significant challenge, which ESA engineers executed brilliantly. Yet, the true test came during Philae's descent. With a decade of meticulous preparation and over €200 million invested, the mission's success, or failure, rested on this single moment. As Philae descended, hundreds of scientists, engineers, and mission controllers held their breath. Philae missed its target during its initial landing attempt, bouncing 2 or 3 times across the comet's surface before drifting away. However, this possibility had been anticipated, and Philae was pre-programmed to handle such setbacks. After maintaining a safe orbit around the comet for another 2 hours, the lander tried again, but the second attempt also failed. At ESA, the tension was mounting. The third attempt was a true nail-biter. Finally, after a final maneuver, Philae successfully landed on Comet Churyumov-Gerasimenko. Although it didn't touch down at the intended location and came to rest at an awkward, tilted angle, the small probe managed to begin its scientific mission as planned, taking measurements and capturing images. Despite the less-than-perfect landing position, ESA celebrated the historic achievement by popping champagne corks. They knew they had just made space history. Back on the comet, Philae had already begun its work. Even during descent, its infrared cameras were fully active, and once on the surface, the lander sent back its first close-up images of the rugged terrain. For the first time ever, scientists on Earth could see the comet's jagged surface around the landing site. Philae detected a regolith layer up to 6 feet thick, a common feature throughout the solar system. Along with gravel, the probe also photographed rocky blocks as large as 16 feet across scattered across the comet's surface. Our planet's water did not originate from comets. To wrap up this video, let's address the compelling question: where did Earth's water actually come from?